Welcome to another video as part of the Pavilion video series. SQL Server Latency, part 1 of 2, Latency for Improved Transaction Commit. In this video, we're going to show you how storage latency matters more to database performance than actually anything else. I am Costa Hasapopoulous, the Chief Field Technology Officer for Pavilion Data. I'll be joined by one of our SQL Server experts and consultants, David Klee, the founder of Heraflux Technologies. So in this video, as it relates to storage latency and how latency matters, we're going to talk about how database transactions affect that, how transaction hardening can affect it, talk about latency and why it matters in SQL Server, and talk about the different storage medium from spinning disks to SSDs to NVMe drives, and really look at the speed of business change and how latency can help in that area. So before we get into the presentation and an introduction of David, let's talk about Pavilion and how Pavilion unleashes the power of Windows and SQL Server. Of course, we work well for every single workload, but if you have super high bandwidth per host needs with ultra low latency, this is where we really shine. Whether that's large or small block sizes, whether that's read or write. Specifically, that relates to SQL Server. So that Pavilion platform that has impressive IOPS and the millions of IOPS and the impressive throughput, but what is most impressive is that latency in the range of 100 microsecond read to 25 microsecond write latency. All of that packed into 4 rack units and over 2 petabytes of usable capacity. Whether you're leveraging that platform for a Windows environment running SQL Server on bare metal, leveraging NVMe-TCP or NVMe-RoCE, we have certified drivers from Windows to support both of those environments. What's really impressive, you can get similar or same performance of bare metal inside of VMware running SQL Server in Windows, leveraging VMware 7.0 and Pavilion support for NVMe-over-Fabrics RoCE for VMware 7.0. So whether it's bare metal on Windows for Windows or whether it's virtualized inside of VMware, incredible performance, but ultimately low latency, which drives incredible results for SQL Server. So our presenter today, I'm excited to introduce the founder of Heraflux Technologies and Sequilibrium Education, David Klee. David is an incredible performance tuner, enterprise DBA, and infrastructure architect, and self-proclaimed geek. David's expertise in SQL Server and VMware are the best I've seen. His ability to intersect the storage, the software, and the virtualized infrastructure or non-virtual infrastructure, and to tune the system to get the most out of SQL Server is incredibly impressive. So with that, I'll turn it over to you, David, and let's learn more about SQL Server.
Thank you very much, Costa. Let's talk about database transactions. As you know, every single thing that happens in a database in terms of data change has to be recorded. Well, the biggest thing for me is to understand how and where this transaction change or reading data seems to matter when it comes from disk. Well, database reads largely come from disk until they're needed more than once and they stay in memory. SQL Server has a very large memory pool. It's called a buffer pool, and it's essentially a storage read cache. So if data is being repetitively read, it's not that big of a deal as long as you have enough memory or the storage can keep up. But when you deal with database writes, this is the business process. This is that change to that history of that object that has to be written to disk. Well, there's a lot of examples for this. It could be a new order gets placed into your ERP system, or you've shipped a product and you want to mark the shipping number. Or a patient was admitted to the hospital and you kind of want to keep track of them. Or money was deposited into your account. All of these are absolutely critical that you make sure that you get this change to disk as fast as possible. Every single change that happens to these database objects, including updates, deletes, and inserts, absolutely have to be recorded to disk to make sure that this transaction is recorded. It's absolutely critical. We can't have data loss in the event that anything big happens to these systems. So as part of the ACID properties of a relational database engine, we have to harden this transaction to disk before that transaction to disk, that change operation, is considered completed. Now, how do we do this? The database is made up of multiple components. So if you take a logical database, usually at a minimum, you're going to find a data file, or in this case, MDF, and you have secondary data files. They're usually suffixed NDF, and then there's a transaction log file, or LDF. This transaction log file, it's not a normal log file. This is quite literally the ledger of everything that is changing inside this database. That's a big deal. So when you place a new order into the system and you go and update this record, the database goes, I've got it. Let's make this change. It write ahead logs, meaning it's going to write to the transaction log first. As soon as the change gets hardened there, then the data file is updated with this transaction. This is absolutely important because the speed at which we can make these changes to disk matters. Business is being held back if we can't do this quick enough. At that point, this thing is now considered done and life is good. If we can do this quickly, life is awesome. Now, the interesting thing here is that every single change that happens, it has to go through this whole process every single time. And it seems complicated, but realistically, this is the speed of the business operation. We have to get this done quickly, or else the business is being held back. So, how fast can we commit this? That's what really matters to true DBAs out there. And for these really large operations, this separates the systems that can scale from the ones that can't. Modern data platforms are not the simple solutions that we had 20 or 30 years ago. Instead of a server with local attached storage running a database, we've now got virtualization in the mix. And we can run a lot of SQL servers, and each SQL server can have a lot of databases, and each database can have a lot of moving parts and objects, and a lot of users and a lot of use cases. The workload patterns in here can be absolutely severe. And if you're pushing this thing pretty darn hard, if your storage can't keep up, everybody suffers. Nobody needs that. These platforms can be pretty complicated when you take a look and really peel back the layers of the onion at what actually comprises the infrastructure stack underneath these databases. It's a lot more than just those database files. So we're going to start at the very bottom. Primary enterprise storage. Now, people really wonder, the database engine has a very large memory footprint because the assumption was made, and historically it was true, that enterprise storage was historically the primary bottleneck to quite literally everything at the database layer. So it's got a large memory footprint to make up for this. Now, the storage performance side, we need to make sure that this area is performing as fast as humanly possible. So latency, the actual round trip time for the database engine to get to disk and back, matters more than any other metric out there. Now, normal storage arrays will do it in milliseconds. I hope you're on stuff that can do it in microseconds because, again, we're talking orders of magnitude performance gains. A lot of folks out there will talk IOPS, or IOs, operations per second. Higher is always better, but it's kind of like saying I've got a brand new Italian sports car in the driveway and it's got a speedometer of 240 miles an hour. To me, if all I'm doing is getting on the highway and driving around to go see friends or things like that, I'm not hitting 240, but 0 to 60 matters. That's latency versus IOPS. IOPS only matter if the demand is there to actually necessitate that high peak of IOPS. And then there's throughput. All throughput is IOPS times block size. And most of the time, the database engine is in a 64K block because that's what we format the Windows or Linux layer to. Could be bigger, could be smaller. Monitor the interconnect throughput to make sure that you're not hitting any ceilings there. But if you had to pick any of these as most important, it's latency without hesitation. Now, if you look at the way the storage has progressed over the years, it started with essentially magnetic record players, which not fast at all. You've got a needle and a head and it spins and it all has to line up and read the data as it flies by. It's sluggish. And then take the controller for that and put it on some solid state cells. Not the most efficient because the controller is not built for the high rates of random activity that this SSD can actually facilitate. So put a SAS head unit on it, make it a little bit better, but then hit NVMe storage. And this is one where they completely changed the architecture. And so instead of one inbound queue with, 32 or 64 concurrent I/O commands, you can now have 65,000 inbound queues, each with a queue depth of 65,000. The random activity and the capabilities of these drives are absolutely astounding. Extreme low latency, extreme fast IOPS, extreme fast seek time for lots of concurrent random activity, which is what your database is. And when you throw this in a virtual environment, you've got tons of random activity on there. So what we need to figure out is get the storage to the lowest possible latency, because that means the fastest possible business operation to disk so we can move forward. Literally, help this platform move at the speed of business and don't hold it back. Start at the bottom. Now, we're going to be talking a lot about how to tune a lot of the layers above, but if the storage itself is not super fast, every bit of tuning that you're doing is secondary compared to the primary bottleneck that is that storage device. In all of my years of SQL Server engineering, storage latency matters more than anything else. This is where I see Pavilion fitting in. It scales, the NVMe media, the PCI switch architecture, the multiple active controllers, all of it matters. Costa's going to show some performance numbers that you really might not believe, but take it from me. I'm an independent consultant designing some of the largest systems in the world. Thank you. This thing works. I love the opportunity to share absolutely nerdy details about SQL Server data platforms. Back to you, Costa.
Thank you, David. Great insights as always. As we summarize this video, let's bring it back to something that's really core to SQL Server, latency. So as we look at a Pavilion storage array, it's always sub-microsecond latency, whether that's bare metal or VMware, whether that's read or that's write. Impressive latency drives lots of things upstream to SQL Server that are all good. It pushes the bottleneck from the storage to somewhere else inside a SQL Server ecosystem. So we have demonstrated through this table that is a disk speed on Windows with a single Windows host and a single NIC, some very impressive latency, whether that's Windows bare metal, the first two columns, Windows TCP and Windows RDMA, the read, and then the first two columns on the right. But what's equally impressive is the latency by taking that same ecosystem and put it inside of VMware. Similar or same latency, or in some cases better depending on the protocol than bare metal. So as we see, latency is key to SQL Server, and Pavilion can deliver impressive latency, bare metal or inside a virtualized VMware ecosystem. Thank you so much for spending time today with us, learning more about SQL Server and how to optimize the SQL Server ecosystem to get the most out of your investment. Special thanks to David Klee, our SQL Server extraordinaire. We appreciate all the partnership and all your insights you've given us today. If you want to learn more, come check out our other videos at www.pavilion.io or reach out to us via email at info@pavilion.io, or of course you can always call us on the phone. We'd love to talk to you about how Pavilion can help you optimize your SQL Server environment and get more out of your investment. Thank you for your time.